Hi, we're going to look at parent functions and quick graphs. We're going to see how quadratics, absolute values, and square root graphs all kind of relate to each other and the different movements that they can make. I'll make a more detailed video explaining some of this later on. Now, parent functions. Parent functions is where all of our graphs kind of come from. Now you're going to see f of x, you're going to see y, they all mean the same thing. You see that, just pretend it says y, whatever. But nonetheless, parent function is what everything kind of stems from. We know that x squared gives us a parabola. Okay, we know that absolute value gives us this V shape. And we also know that this square root gives us kind of this half a parabola on its side. Each one of their vertexes is at 0, 0. Now, the numbers that we have on the outside at the end, inside, and even in front, they all change our problem a certain way, but they all change them, they all change for the same. Okay, so top one. Whenever you get a +1 or even a -2, our graphs are going to shift up or down. When you have that +1, our graph ends up shifting up. When you have a -2, it shifts the whole graph down. Same thing happens with our V's. That +1, we go up 1, we go over. We go -2, we go down, and you got your V's. And then finally, with the square roots, take that half a sideways parabola, it's up on the top, and move it down. So those numbers on the outside shift our graph up or down. It doesn't matter what that graph looks like, but they all have that same movement as long as you know what that basic parent function looks like. Okay, so if a number on the outside shifts a graph up or down, numbers on the inside shift it left or right. But this time it's not so easy. This time things are opposites. And the reason why, you take whatever's on the inside, set it equal to 0. That number you would come up with, x would be a +2. So in this case, we move, since it's a negative, we move in the positive direction, left or right. You take that 3, set it equal to 0, subtract 3 from both sides, x equals -3. That's where we're starting. It shifts our graph to the left this time. Okay, same thing. Let's look at the V's, the absolute value. -2 on the inside, we shift to the right. We have a +3, we shift to the left. Things are backwards here. That -2 shifts to the right. The +3 shifts to the left. All right, so every one of these shifting, every one of these movements, it's all the same. Now, what about if you've got a number in front? So that 2 out front is going to do something. It's going to kind of make at least the parabola and our absolute value V, it's going to make them skinnier. Again, if you're not so sure, make a table of values, and we'll look at some of that in another video. So go back to that origin, and this time I'm going to exaggerate a little bit. We get a skinny V. Now, if having a 2 here, and it's really going to get skinnier or thinner when you have a number greater than 1. When this number out front is bigger than 1, it's going to get skinnier and skinnier and skinnier. In the reverse, if you've got a number smaller than 1, and I'm only talking from 0 to 1, forget negatives, just any fraction smaller than 1, if that gets skinnier, this is going to get wider. All right, let's take a look at the V's. The V's are going to get skinnier, and the V's are going to get wider. Now, what does that have? How does that work down here with this half a parabola? Well, I'm not so sure. Let's try and figure this out. If I plug 0 in for x, square root of 0 is going to be 0. 0 times 2, Still 2. So we're starting off at that origin. Good. Plug a 1 in there. Square root of 1 is 1. 1 times 2 is going to give us 2. So when I put a 1 in, I get 2 as an answer. How about if I put 4 in? If I put 4 in, I get 2 as an answer. 2 times 2 is 4. So it looks like this is kind of getting a little stretched up a bit. What does that mean if you've got the 1/2 now? Well, this thing's going to get even tinier. It's like we're kind of squishing it down. So those skinny, skinny, and we kind of like pull that up. These ones get wide, wide, and we're stretching it out so it kind of shrinks it down. Then the very last one, we have negatives. So when you have a negative, basically we're going to the very, very front, this parent function, flip everything. So we have a parabola that now opens down. We have a V that opens down. And we have this half a sideways parabola that opens down. And that is parent functions and quick graphs with quadratics, absolute value, and square roots.